Hello students, this is Afrin Tasildar, your mathematics lecturer, and we're going to start with the topic continuity and differentiability. First we will see what is our continuity, then we'll head up to the differentiability part. You have studied about your limit part in your previous class, that is in your first year. You know how limit function works when it exists. When your LHL and RHL both are equal, we tell your limit function is exist. Suppose y is equal to f of x and let x is equal to a, taking a general point. Then LHL, how it works, limit f of x as x tends to a minus. Your minus, your superscript represent your LHL part. Your RHL is equal to limit f of x as x tends to a plus. Your positive side represents your RHL. If the both value is equal, then we tell the limit function exists. Your continuous is just the extended part. The point whatever they have given at x is equal to a, in your function, your f of x, whatever they have given, wherever the x value is there, you are replacing it with the point what they have given. And so we tell it as f of a. So if f of a, your RHL, your LHL, if 3 is also equal, then we tell the function is continuous at that point. The value of a function y is equal to f of x at x is equal to a is f of a, which means the function f of x, whatever the function is, in the place value of x, you are putting the point that we tell as f of a, right? Here we have taken as a, so it becomes f of a. So whatever, when you solve it, when you get the same answer, then we tell it is continuous at that point. So your LHL, RHL and value of a function at that point, if 3 is also equal, then we tell it as continuous. Now tending towards that point, you know in the x tends to, which means it is tending either to the left hand side or right hand side, but not exactly equal to that point. Now suppose I have taken here x tends to 2, which means if I am taking LHL means it will be less than 2, that is 1.9, 1.99, 1.99, whatever. If it is more than 2, you can tell 2.0, 2.01, 2.02, such a way, but it will be not exactly equal to 2. That only, which means tending towards, which you apply your limit when you study it. Graphically, if I teach you, I have taken here a function. If f of x is equal to 2, if x is less than equal to 0, minus 1 if x is greater than 0. This is a branched function. Yes, it is a branched function. So when I draw the graph, what they have said, if x is greater than 0, it is what? Minus 1. So here in minus 1, see, I have drawn here the graph. And when x is less than 0 or equal to, which means the other side, right? Negative side. Less than means what? It is negative side. So negative side or equal to 0, they have said it 2. So I have drawn here also graph. You can see here I am drawing here one line and here one line with lifting the pencil or pen or my hand, anything. Okay. So if I am lifting and drawing the graph, which means that graph or that function is not continuous or a discontinuity, where clearly you can see your LHL and RHL is not equal, and I am drawing the graph with lifting my pen or pencil. If I am drawing the graph without lifting it, then you can tell that is continuous. If I am lifting and doing, that is not continuous, in a simple way. Next graph also I have done in the same way, the same explanation it goes. So no need of explaining the same. This, if you want to, you can write it in your notes. It's just for your understanding. Better you write it in a definition way. If you go, I hope all are making notes, so just write it down. Okay. Continuity at a point x is equal to a. A function f of x defined on a subset of real numbers is said to be continuous at a point x is equal to a if limit f of x as x tends to a is equal to f of a, where a belongs to d of f. D means where d is your domain, Domain means what? Where it is defined, the function where it is defining, like particular point we are telling. If it is we are telling 2, defining that function at that particular domain, like tending towards negative or positive to that parts. Yes. If f of x is not continuous at x is equal to a, then f of x is discontinuous at x is equal to a, and a is called a point of discontinuity of function f. Note it down. This your mathematical definition for your continuity. Here you have again working rule to check the continuity of a function. So first point, check whether the function f of x is defined on a subset of the set R of real numbers. We have to just check that whether that function is defined on that subset or no. Second is evaluate the LHL limit f of x as x tends to a minus and the RHL limit f of x as x tends to a plus. As I have said you, we have to check our LHL and our RHL. Okay, these two should be equal to the common point L. As you have said, first you will check for the function, right? Whatever the function they have given for that particular point, checking it, and then going for LHL, RHL. If these two is equal to that limit L means particular point, show that limit f of x as x tends to a is equal to f of a, which means your left hand side, your right hand side, that is limit f of x as x tends to a should be equal to f of a at that point. This conditions it follows, which means it is continuous at that point. This is your continuity, your working rule. Please just note down your notes